evaluate this integral. We have square root of 4 minus x square on the bottom. So that's the form of square root of some number square minus some function x square, so u square. And we know whenever we have this form root a square minus u square, then we have to make this substitution u equals a sine theta. Okay, we need to make this substitution. So in this case a is 2 and u is x, so we let x, that's u, equals 2 sine theta. Why we are making this substitution? Because then we can get rid of this square root. Okay, that's the x part. Now we are trying to convert this integral in terms of new variable theta, so we need to find for dx. So find the dx over d theta equals 2 derivative of sine is cosine theta d theta. Okay, with this substitution, then our integral, I'm writing I as the original integral, that equals x is 2 sine theta over root 4 minus x squared. X squared is 2 sine theta quantity square, which is 4 sine square theta, and dx we just found 2 cosine theta d theta, 2 cosine theta d theta. Let's simplify the bottom. That is now 2 times 2, 4 sine theta cosine theta, that's on the top, over, and we have d theta over here. On the bottom 4 we can factor. Let me work out on the side to save space. 4 minus 4 sine square theta, that's in fact we can factor 4 out inside. 1 minus sine square theta, and we have now square root of 4. 1 minus sine square is cosine square, so root 4 cosine square theta is root 4 is 2 cosine theta. So we have 2 cosine theta on the bottom. Then we can cancel, simplify, cosine cancel, 2 divides 4 2 times. Okay, then we have what is left, just 2 sine theta d theta. Okay, now we integrate and we will be done. For we can pull 2 outside because 2 is constant, and we have now sine theta d theta equals 2, antiderivative of sine is negative cosine. I'm going to put negative on the front, negative cosine theta plus c. This would be the final answer, but we have to write our final answer in terms of the original variable x. Okay, now we need to write cosine theta in terms of x. For we need to use the original assumption. Our assumption was x equals 2 sine theta. From this we need to determine what is cosine theta. Okay, so x equals 2 sine theta. Let me do a little bit over here. X equals 2 sine theta. X equals 2 sine theta is same as sine theta equals x over 2. And let's write the corresponding right triangle. Okay, right triangle, not a nice one. Let me try to draw a better one. Okay, with angle theta, sine is x over 2, so a square plus b square, this is right, a square plus b square equals c square using Pythagorean theorem. Now we need to determine b. So x square plus b square equals 2 square, x square plus b square equals 2 square 4. Let's find b. Subtract x square from both sides, we get b square equals 4 minus x square, and b is, take a square root 4 minus x square. So b is in fact this side is 4 minus x square, and we know cosine, because we were trying to find here negative 2, cosine is base over this side. Okay, so root 4 minus x square over 2 plus c. That's the final answer, but we can cancel 2 and 2, so the final answer is negative root 4 minus x square plus c. That's the final answer. We can check if our answer is correct. All we have to do is differentiate this function. When we differentiate, we need to get the original function x over root 4 minus x square. You can always check.